Hi. Okay, so what I want to do now is to be able to have you look at graphs, like acceleration versus time graphs, and be able to go backwards to the velocity, and then, for example, go from the velocity to the displacement or position. So that's what I've got planned for the next example. Let me pull it up. Okay, so I'm going to do part A in this video and then part B in the next video so they don't get too long. So here, a particle starts from rest and accelerates as shown in this figure. Determine the particle speed at 10 seconds and at 20 seconds. So I'm just going to do that part in this video. So if you look here, first of all, at our acceleration versus time graph, you can see that we have a constant acceleration between 0 and 10 seconds, a constant positive acceleration. And then between 10 and 15 seconds, we have 0 acceleration. Now remember that 0 acceleration doesn't mean no motion, it just means no change in motion. And then from 15 to 20 seconds, we have a constant negative acceleration of minus 3 meters per second squared. Remember that a negative acceleration doesn't necessarily mean slowing down. If, for example, the velocity were in the negative direction, the acceleration were in the negative direction, it would be speeding up, okay? Just for an example. That's not what happens in this problem. But, okay, so it's just the direction of the acceleration. So now I've worked this problem out for you here. Okay. So first of all, we're going from the acceleration to the velocity, and that's going to be the area under that curve. Let me pull this up over here. Okay. Okay. So your change in velocity is the area of that curve. Another way to think of it is that since delta V is Vf minus Vi, your final velocity minus your initial, that if you just want your final velocity, which is what it asks for in this problem, then that's going to be Vf is equal to Vi plus that area. Side of the equation. Now there's a key word here. It says the particle starts from rest. That means that the initial velocity is 0. So here I've written down my initial velocity right here is 0. And now I'm going to add in that area, and that's base times height, because this over here is a rectangle, and that's the formula for area of a rectangle. So we have 0 plus base times height. So if we find that for that first 10-second time interval, then we have 0 initial velocity plus the base is 10 seconds times the height, which is 2 meters per second squared. So there's our rectangle. And that's 0 plus 10 times 2, which is 20. So that gives us 20 meters per second for our velocity or speed at 20 seconds. Okay, next, we're trying to find that speed at 20 seconds. So that means that we have to sum up everything that goes on over that entire 20-second time interval. It's not as hard as it sounds because we've already done the first 10 seconds. So just like in the first 10 seconds, we have the initial is 0 plus for our first 10-second time interval, 20 meters per second. Now, the next time interval isn't hard either. That's 10 to 15 seconds, and that's a 0 acceleration, which means no change. And there's no area under that curve that lies on the axis, so that gives us here. Now, between 15 and 20 seconds, this is a little tricky because it's underneath the time axis, and that means we're going to have a negative area. So here we have, again, base times height because it's a rectangle. The base is 5 seconds. The height is minus 3 meters per second squared. So now to find the speed at time 20 seconds, I just sum over everything that's gone on over that whole time. 0 plus 20 plus 0 plus negative 15. So that's 20 minus 15, which gives me 5 meters per second for my final velocity or speed here. Okay, velocity and speed are kind of interchangeable here. Remember, speed is the absolute value of the velocity, so that's positive, 5 meters per second. That's our first part of our question. I'll do part B in the next video.